All right, everyone, buckle up. We're going deep today.
Deep into fusion.
Got it. Specifically, this OpenStar company.
Yeah, I saw that article you sent over. Pretty wild stuff. New Zealand, huh?
Right. Who would have thought? But they're claiming they might be leading the pack in the race for clean energy.
Hmm.
Limitless clean energy.
Yeah.
Fusion power.
Fusion. The holy grail.
Exactly. But, I got to ask, is it all just hype?
Well, that's what we're here to find out, right?
You bet. So for anyone just joining us, we're diving deep into OpenStar today. A fusion startup making some bold claims. They've got this new approach, a different way of doing things, and we're going to break it all down, figure out if they're really onto something revolutionary or if it's, well, hot air.
Yeah, hot air. I see what you do there.
That too.
Yeah.
But hey, let's get serious for a second. Fusion, as a concept, is amazing. And we were talking
Okay.
about harnessing the power of the stars, right?
Yeah, the sun, our closest star, is a giant fusion reactor. It's been powering life on Earth for billions of years.
Billions. It's mind-boggling. But as you know, replicating that here on Earth, that's the tricky part.
It's not easy. I mean, the challenges are immense.
Tell me about it. What's the biggest hurdle, would you say?
Well, you gotta understand, fusion is about forcing atoms together, right? But atomic nuclei, they're both positively charged, like trying to push two magnets together, same poles facing. They resist.
Yeah, they repel each other.
Exactly. And the sun, it uses gravity, immense gravity, to overcome that repulsion and force those atoms together. We can't quite replicate that here on Earth, at least not on that scale. So we need other ways.
Right, hence all these different approaches. I mean, the article mentioned there are over 40 fusion startups out there.
Yeah, it's a bit of a fusion boom right now, lots of investment, lots of different ideas. But honestly, some haven't panned out as well as they promised. Like, remember First Light Fusion?
Oh yeah, they were making headlines a while back. What happened there?
Delays, mainly. They had these grand plans using projectiles to create fusion, but it's proven more difficult than they anticipated. Same story with Commonwealth Fusion, actually. They're using a more traditional tokamak design, but they've hit some snags too. So a healthy dose of skepticism is warranted, I'd say.
That's a good point. Not all fusion is created equal.
Precisely. And that brings us to OpenStar. They're trying something really different.
Yeah, this dipole design, right? The article was a little light on the details.
Right, so most fusion experiments, they either use magnetic confinement or inertial confinement. Magnetic confinement, that's your tokamaks, big donut-shaped magnets that try to contain the superheated plasma where fusion happens.
Okay, I kind of remember those. What was the other one?
Inertial confinement, that's where they blast tiny pellets of fuel with lasers or projectiles to try and trigger fusion.
Ah, okay. So OpenStar, they're not doing either of those.
Nope, they're going with this dipole approach. Imagine a donut-shaped magnet again, but instead of being held in place by all these external structures, it's levitating.
Wait, what? A floating magnet? Seriously?
Yep, it's pretty wild. And that creates this special magnetic field, a dipole field, which is really good at containing the plasma.
Okay, but how does a floating magnet make it easier to contain the plasma? What's the advantage there?
Well, it helps with turbulence, for one. You see, in tokamaks, the plasma can get all churned up, which makes it harder to control and keep stable. The dipole field, it's more, well, elegant, less turbulence, which means better confinement, potentially.
Elegant, huh? I like that. So easier to control the plasma, and it's simpler in design, right? No need for all those massive support structures.
Exactly, which could mean cheaper and easier to build. Less complexity, fewer things to go wrong.
Sounds almost too good to be true. What's a catch? There's got to be a catch, right?
Well, keeping that magnet perfectly levitated, that's the tricky part. It has to be super stable. Any wobble, any shift, and the plasma could escape. Poof, no more fusion.
Ah, I see. So it's like a balancing act, a very delicate balancing act.
Exactly, and that's where the AI comes in.
Oh yeah, the article mentioned they're using AI to control the magnet, but how does that even work?
Think of it as a super fast, super precise autopilot system. They've got sensors monitoring the magnet's position constantly, and the AI analyzes that data and makes tiny adjustments to the magnetic fields in real time, keeps everything perfectly balanced.
Wow, so it's like this constant feedback loop. The AI is learning and adapting to keep that magnet levitating.
Exactly. And it's got to be fast because we're talking about plasma that's incredibly hot and moving incredibly fast. Any delay,
Yeah.
and things could go haywire.
It's incredible how much technology is going into this. It's not just physics anymore. It's computer science, AI, engineering, all working together.
Absolutely. It's a real testament to human ingenuity pushing the boundaries of what's possible.
They've already had some success with it, right? I remember reading about that.
Yeah, OpenStar managed to contain plasma at 300,000 degrees Celsius, which is, well, scorching hot.
300,000 degrees, I can't even imagine that. How hot is the sun again?
The surface of the sun is around 5,500 degrees Celsius, so we're talking about something over 50 times hotter.
Whoa, okay. That puts it into perspective.
Yeah.
But wait, for how long did they maintain that temperature?
They held it for 20 seconds.
20 seconds. That doesn't seem very long.
It's not in the grand scheme of things, but for a company at this stage of development using this totally new approach, it's actually quite impressive. It shows they're on the right track.
Okay, so it's a good sign, but we're still years away from plugging our toasters into a fusion reactor, right?
Yeah, we're not there yet. OpenStar is saying they could have a working reactor within 6 years, which, that's optimistic. Most experts think it'll be closer to 10 or 15 years before we see commercially viable fusion power.
Okay, so it's still a ways to go.
Right.
But let's say, hypothetically, they do pull it off. 6 years from now, we've got fusion power. What does that world even look like? What changes?
Well, for starters, imagine a world where we're not so reliant on fossil fuels anymore. No more oil spills, no more coal mines polluting the air. It could drastically reduce our carbon footprint.
Yeah, that's huge for climate change, right?
Absolutely. And think about the energy poverty that exists in so many parts of the world. With fusion, even remote villages could have access to cheap, abundant energy.
Wow. It could change lives. Really uplift entire communities.
It really could. And think about all the industries that rely on energy. Manufacturing, transportation, everything. Fusion could revolutionize it all.
It's almost too big to grasp the potential ripple effects. It really makes you think, what would you personally want to see change in a world powered by fusion? What possibilities does it open up?
That's the exciting part, isn't it? Fusion has the potential to solve so many of the world's problems. And it's up to us, all of us, to figure out how to harness that power for good, to create the future we want.
It's almost like a gift. A gift that comes with a lot of responsibility.
Exactly. A gift and a challenge.
Well said. And to everyone listening, if you're as fascinated by this as we are, definitely check out the full article on OpenStar. We'll link it in the show notes. It's mind-blowing stuff.
It really is. And it's a good reminder, especially around this time of year, that there's still so much to be hopeful for.
You got that right. The future is bright.
Yeah.
Maybe even fusion-powered bright. Thanks for joining us on this deep dive.
And happy holidays, everyone.
Happy holidays.